Okay, so we're going to learn a little bit about coordinates and coordinate planes. We're going to look at one of the things you have to do in here right now is to use coordinates to prove certain things. So what I really want you to see is I want you to see a circle for a little bit. We're going to talk about this, but before we talk about it too much, I'm just gonna show you some stuff. Okay, so here we have a circle, and point B is a point on the circle, but I'm gonna make it disappear by clicking that button over there, right? I'm gonna place a point on the circle. So this point is on the circle. And the reason I use it instead of B is because if I move B in any way, it changes the radius. The radius of this circle I just drew. Okay, I created this circle with the circle tool by identifying the center and by identifying the radius. And A located the center, so if I move A, the circle changes. And B located defined the radius, or really the distance between D and A, B and A. So if I adjust A or B, I make that circle smaller or bigger. I don't really want to do that. I'm going to leave A alone. I'm going to leave B alone. But I want us to still see A for a moment. But I'm gonna move C around the circle. And I want you to notice that even when I try to take it off the circle, it will not come off the circle, because the way I created it was I used this tool, point on an object, and that then requires that it stay on the circle, the object that I placed it on. So we have a point on this circle, and the reason for this is I want you to notice a very important thing about that. Now what I'm going to do is I'm going to make a construction so you can see this. I'm going to construct a line that is perpendicular to the x-axis and goes through point C. And then I'm going to construct another line that's perpendicular to the y-axis and goes through point A. And now what I'm going to do is I'm going to find the point where they intersect. So this point right here is where they intersect, right there. Okay? So now I'm going to take those other lines off. We're not going to worry about them. I want you to focus on D for a minute as I move A around. I want you to focus on D. Now notice that as C goes around the circle, stays on the circle, D stays inside the circle with the sole exception of when D and C are at the same point, which is just at one exact location. But otherwise, you know, they are very close to the same point, but they are not the same point. But what do I know about C and D? Well, what I know about them is that they form a right triangle. I'm going to prove that to you here. I'm going to prove it by taking its measure. Okay, I'm going to measure the angle of ADC. You can see that it's 90 degrees, and that measure stays at 90 degrees even as I move D around. Oh, I go down here, it says 270, which is, you know, the outside measure of that angle is, you know, ADC on the outside is 270 degrees, which means the interior angle is still 90, right? So it is a right angle. And my point is this: for every point on the circle, there exists a point in the circle such that a right triangle can be formed. Okay, with that point in the circle being the vertex at the right angle of that triangle, such that the point in the circle and the point on the center of the circle and the point on the circle form the radius of a right triangle. So the reason for that is because of Pythagorean Theorem. So let me just put that down. Now you're going to get a lot into this later on. You're going to actually use this a lot later on in math. In this class, we're going to have a whole adventure just really kind of focusing on this. But what Pythagorean Theorem says is he says you can take and square each of the legs of a right triangle and add them together, and their sum will be equal to the square of the hypotenuse. So I'll put a little space in here so you can see what I've written a little better. Okay, if you're new, you might not realize that that caret there means superscript, so h caret 2 means h squared, and L squared plus L squared. So what that is that's the that is the leg squared here plus the leg squared there is equal to hypotenuse squared there. And so what it turns out is that we can write ourselves an equation. And you will derive that later on and you'll explain that equation. But for right now, I'm going to give you that equation. And that equation looks like this. It basically says x minus h squared plus y minus k squared is equal to r squared. So this is where we'll use this, where the obvious first. R is the measure of the radius of the circle. And where h comma k is the location of the center of the circle, and where x, y is a point, any point on the circle. Oops. Okay, so we got a little bit of information there, and now the key is how are we going to use that in this adventure? Well, one of the first things you're going to be asked to do is you're going to be asked to prove that a point exists on a circle with a given center and a given location. So let's see how that be done. I'm going to switch to my calculator here, and we're going to actually see how that would be done. Okay, so let me pause here. Okay, so basically, I'll give you an example here, and we're going to say that there's a problem that says to you, okay, let me close that out, sorry. All right, it says, okay, you have a circle, okay, and we're going to say that this circle here exists with the center at the origin, so that's 0, 0, okay, and now they're going to tell us that the point 0, 2 exists on this circle. So we're going to say over here, we would go, over 2 units if we think about the y and x axis. So we would go, we would go directly up 2 units, okay? So we have the center at 0, 0, and we have the point 0, 2 on the circle. So now what the problem is going to ask you, it's going to try and say, prove that the following point, and we'll use 1 comma the square root of 3, prove whether or not it lies on this circle. And that's given that the center's at the origin and that the point 0, 2 lies on the circle. So we know a few things. In order to use, first of all, let's go over that formula for a circle again. I gave it to you before, but it was x minus h squared plus y minus k squared equals r squared. And remember, r was the radius, h and k are the x and y values of the center, and x and y are the points on a circle. So we could plug in these points and hopefully we would find it all. But clearly what we're going to need to know to be able to test anything on this circle is we need to know the coordinates of the center. So that's the coordinates of the center. Okay? We have that information here, right? That's 0, 0. So we can fill out that part of the equation, x minus 0 squared plus y minus 0 squared is equal to, now we need, the other thing that we need is we need the radius. Okay, so the radius, now you can use the distance formula on this. You have 2 points, x and y values. If you want to use the distance formula, that's fine. But actually, sometimes it's just good to think about it for a minute. This center is at 0, and this unit and this point on the circle is at 0, 2. So just think about how many units away this point on the circle is from the center. Now think about that. So it would have gone up from here, up directly up the y-axis. How far? There's 1 unit and 2 units. For it to get up here, right, to 0, 2, have to have moved 2 units. So what we're going to do is we're going to go ahead and plug in that the radius, which is defined as the distance from the center to any point on the circle, the radius is going to have to equal 2. So we'll put 2 squared there. And now we can take this equation that we have and we can kind of simplify it. So x minus 0 is x, so it's just x squared, plus y minus 0 is just y, so it's just y squared, is equal to 2 squared, that's 4. So now we have a simpler equation. And now we have to run the test. The test says place 1 root 3 inside of here. So we're going to, the x value is 1, so we'll say 1 squared plus root 3 squared is equal to 4. All right, and let's say you're just not all that comfortable with your math, and that's fine. I don't want you to struggle with geometry concepts because you're uncomfortable with calculations. That's what we have a calculator for. So we're going to just go ahead and try our calculator here. We will go 1 squared. Now, I'm getting that. I'm going to dim this just a little bit so you can see the screen a little bit better. But, you know, I'm using 1 and my square button here, right? Plus 3. Oh, no, it's not 3. Hold on. It's the square root of 3 squared. So I've got to do the square root of 3. Now, the square root of 3 is this button again, but it's the blue part. So I have to hit Control. I don't have to hold down Control. If I press Control, a little Control button comes up. And then I can hit that x squared button. And now I have my radical, so I can put the 3 inside. So that's the square root of 3, and then I put the square outside that. Okay, notice that it automatically put it in parentheses for me to say square the square root of 3. And then I can say equal to 4. And I can just hit enter, and given that it's true, then I know that it is true. But what is it? How can I do this by hand? 1 squared is 1. So there we have 1 plus... And over here we do the square root of 3. So there we go. What is the square root of 3 squared? Well, that's 3, right? And that makes a lot of sense because the square root of 3 are the two parts, the two factors that get split apart, that when they multiply together they become 3, right? And if we square each of those factors, this means the factors that multiply together become 3. And if we square them, then we're going to get 3 again. So is 1 plus 3 4? Well, 1 and 3 is 4, so 4 equals 4, and that is a true statement. So that's what the calculator's done. It's run through that and said it's a true statement. So that means that we should be able to confirm that this point does lie on the circle. So that's what we're going to do. Now let's go back to GeoGebra real quick, and we'll make the circle. So here we go. I'm going to place a circle. And actually, you know what I'll do? I'll place the points. So we'll place point Z is, well, I'll put that at, Z is at 0, 0. And we'll call it let's call it point X is at 0, 2. Okay? We'll construct a circle using this tool by clicking on the center and on X. And now we'll enter in point P, I'll just call it P, where they said it would be 1 comma square root 3. I think that's hopefully going to, now don't understand the square root of 3. So how can we put that in if it doesn't understand the square root of 3? Well, we'll check right here. Yeah, there's something. We got some symbols here. Have anything that means the square root? Well, Mr. T is not prepared for this right here. You should have, I don't know, I should have something that allows me to do this, and I don't know. Let me pause and I'll come back once I figure that out. Okay, I figured out how to put it there. It goes in like this. It goes, I'll make Q go there as well. Q equals 1, comma, and then you do SQRT like I thought, but then you have to put it in parentheses, and so that it knows what is taking the square root of it. And there you can see that P and Q ended up at the same place. And the interesting thing is they're both right on our circle, just as we proved that they would be.